There we go. So welcome to episode 64 of Quarkus Insights. And I'm going to be very quick and just say we have very few news. There's a 2.3 on its way. Oh, sorry, we did release it, and there's a 2.3 on a CR1 on its way.
Exactly.
That's about it, right? And then I'm going to leave all the time I can to KimJohn, who's he came to our attention, I guess, like a few weeks ago when we started talking about this little idea about how you can simplify the build in Quarkus. And he had a lot of ideas, and he started talking about, hey, if you've improved our platform X, like X plus Y numbers, and Quarkus was this much better. And we were like, wait, like, what are you talking about? Well, of course, it was happy to hear, but he was like so detailed about the things, and he knew how much the different things had improved. So we thought, hey, let's get on insights and see, what that all is about. So that's what today's episode is. So KimJohn, who are you, and want to introduce yourself a little bit? And then
So I'm the principal of Logic Drop and one of the architects, but also an evangelist on technologies, usually exploring how we can apply new technologies to not only better our product, which is actually built on top of Drools. It's a cloud-hosted rule platform. And you'll see as I talk, long before Cogito or Quarkus, we essentially wrote our own key server and workbench in native and Kubernetes, which was challenging to say the least, but it's worked great. And with that, since we spend our time improving client processes, we always are constantly looking at our own process. How can we be faster? How can we deliver better? How can we be more effective across our team, not just individual silos of developers? We want everybody to be able to play equally in the same code base, the same deliverables, and have full responsibility throughout that life cycle. And that's pretty much how we came to Quarkus.
Cool. And when you say developers, because on your emails, you seem to be talking about you have a mixed team, not just Java developers, but also like Node or Java, like other
Exactly.
things?
Exactly. So if you think about it and you look at the classical divide of just front end, back end, and operations, and generally within our organization, we're not the biggest organization, so people wear many hats. What sparked this was we started to see a decline in our own agility. Front end was waiting on back end because back end had to look at a bug or implement a feature. Back end was waiting on operations because operations had to configure the cluster or the services or the native configurations. And that was slowing us down. So we set out with a new initiative to take our existing platform and say, everybody's going to look at Quarkus, whether you're a Python developer, a Node developer, or a Java developer, and a varying skill sets. And I have a pretty strong core team. We saw common pain points across the board, didn't matter who it was. And what it came down to was, if you think about this analogy, when you were a student in the university, and you wrote that first Hello World program, where'd you wrestle? It wasn't in writing Hello World. That's pretty straightforward. You probably wrestled in how did you set up your environment? How did you configure it? And so we went out and polled not only our own staff, but quite a few college kids. And it was the same comments across the board. I very easily could write system out println hello world. Took me forever to figure out, do I need a JRE? Do I need the JDK? What's this class path thing? Oh, I'm on Windows. This is completely different. So we took that to heart. We looked at our own processes and we tried to figure out where are the bottlenecks? What's slowing us down? And it really came down to configuration and setup being the primary reason that we couldn't move as fast as we wanted to. And then with those bottlenecks between the different teams, we wanted to get rid of those and be able to move faster. So a Node developer, at the very least, can read the code base, get his environment set up, and at least pinpoint where an issue may be rather than waiting for somebody. And when you're not Maven savvy or Java savvy, and even if you're experienced, we've seen that has varying levels of being able to maneuver. How do you get rid of those barriers? And that's really kind of what brought us to Quarkus. And after a few short sprints, the difference was phenomenal. I can't even speak highly enough about a complete night and day change from where we were to just prototyping. We weren't even fully in Quarkus, and we were already seeing these crazy improvements in our process across the board.
Awesome. Okay. Well,
that sounds awesome.
Yeah, no, because and I know one of the things you mentioned was this, which I'm looking forward. I probably think you're going to cover it, but this, you were saying, hey, you like the fact that Quarkus generates you Kubernetes descriptors. That it, which by the way, we didn't. It generates a best guess. Like Quarkus has understanding of what you're running, and therefore we can tell you, oh, there's a health check, there's a life check here, and other things you want to do. So we can generate something that'll work on most clusters out there. But it sounds like that was enough for you guys, and that seems like you can kind of strip out all that setup you had in Helm chart or something else before.
Oh my gosh, the Kubernetes was just icing on the cake. So if you think about it, as a system evolves and you get more and more into the microservice approach, or even going towards true cloud native, it gets really hard to orchestrate 50-something microservices on a local development platform. Whether you want to run it in Minikube, Docker Compose, however you want to run it, getting those all up and running and talking to each other is really painful. Yeah. Going along with that, like you said, with the Kubernetes side, we manage a whole set of projects. We actually had to turn developers into DevOps engineers. That's all they did was manage Helm charts and configurations and cluster management. And they weren't writing code anymore. They were spending all of their time in the day-to-day. How do you get the cluster running? How do I configure the service? Deployment. We always would go through our DevOps team almost like a build master and say, I want a full deploy. So we had to wait to do that. And that had to be orchestrated as well. When we went to Quarkus, the Kubernetes descriptors that were built out, one allowed us to get rid of, I want to say 15 or 20 separate Helm projects that were being managed individually, bring those manifests closer to the service, integrate it at our build system at build time, do any configurations or additional annotations that we needed. And it was a one-stop shop for each service that we were able to automate and deploy. And we've had zero problems on the Kubernetes side.
Nice.
And we're using health check. In fact, it's been so seamless. I'll actually show how we use the exact same build, and we can flip between Minikube, Kubernetes, or just running straight up with Quarkus Dev.
Cool. Well, let's go. Do you want me to share your screen?
Sure, please.
I'll just say that I didn't envision anybody being so enthusiastic about the Kubernetes stuff. I mean, I knew when I did this with a colleague that it'd be useful, but yeah, I never imagined it'd be this useful.
Oh, and again, if we look back, we'll keep going back to how do we simplify the process. One, the descriptors are very clean. So they've been very easy to work with and configure. In fact, it's been so easy to configure, we centralize them in one dependency, and all our other dependencies just carry that along. Except for the ingress, which right now, as we start to move more towards native, that'll start to change. But aside from the ingress, nobody touches Kubernetes at all. It just comes out of the box for us. So it's worked great. In fact, if anything, it's actually even added more. We've got service accounts. We've got full control of the annotations. We're not dealing in Go to manipulate our Helm scripts and, oops, I forgot a dot, or I forgot a, I have bad formatting, which has thrown this off for days. Things like that are all gone. And that goes a long way in rapid deployments. And where we go from a production deployment generally taking about a full day. And because it took a full day, we put it into a cadence of every 30 days because it had to be very well coordinated and orchestrated. I'll do a full deployment right now in 30 minutes. And not only can I push to my higher environments of staging or production, we actually introduced, because of the Kubernetes plug extension, we actually introduced the ability to create preview environments where I can do a spot deploy the 1 or 2 services that I'm working on, and then the rest of them just point to a higher environment. So it's given us an ability to test in an isolated mode, which we never had before.
No, but I'm really happy to hear that you guys managed to do this, and because we've gotten the feedback of no, we don't want to have Quarkus anyone to manage the community YAML for us. We want to use GoCD and something else, which, by the way, is perfectly valid if your organization is that way and it makes sense for you. It's not a bad thing. But I always felt that the way we've done it in Quarkus allows for exactly what you talked about. Like if you're a team that is fairly small and needs to deploy a lot of, what is 1 or 50, because we are kind of uniform. Like if it's all Java apps, all Quarkus apps, yeah, the deployment script doesn't change. Like it's all the HTTP endpoints and some health checks, and that's it. Everything else is small things that you can, as you said, can just add into the configuration, and off you go. And you can replicate them, you can move them around, and yeah, that's awesome.
Well, the other nice part about it is, if I want to bring in a new service, right now we just literally copy and paste a template, but I'm up and running in 10 minutes, and that's deployable into the cluster. Where before we would have to file a ticket, have somebody build out the services. Again, you've got this chain of dependencies. Now we're not waiting. I can deploy a service, and we do this quite a bit. I'll just throw a service into the cluster or a feature. Oh, that's terrible. Dump it. No loss, no lost effort from my part, no risk of messing up with anything else. It's completely standalone with its Kubernetes configuration.
Very nice.
Amazing.
Let's get started on your slide deck. Hopefully not too long.
Well, I'm gonna run through this slide deck. It's probably the least exciting because I have a lot of examples to actually show. And we kind of talked a little bit about that background and philosophy already. And again, we go back to the complexities in improving your developer experience don't really lie in the code as much. It lies in how do you get that environment set up and configured efficiently and quickly so that all developers can test, develop, and deploy as fast as possible without bottlenecks between teams. In our environment, we don't want to wait on somebody having to build out a configuration even though our service is ready. We want to get that into play, and if it's bad, we want to pull it out as quick as possible. And that's what we've found by moving to Quarkus, is that we have been able to completely streamline our operations and see across the board at least a 50% reduction in what we thought was actually a pretty smooth process to begin with.
50 as in 50?
Yes.
Okay, nice.
So, in fact, and here are actual numbers. And we were talking a little bit earlier. We track everything. So we track the time a ticket comes in all the way to when it's deployed. We do fire drills to manually see how developers spin up a system or get onboarded. And we cover we try to see how can we optimize our processes. And part of that is based on quantitative numbers. Some of it's also based on, well, where do I see the stumbling blocks when somebody's trying to get set up or write a feature?
KimJohn, when you say fire drill, you're not talking about like fire in production. You're talking about, hey, you now have a developer. You now go set up a new service. Let's see how fast you can get there and see what holds him back. Is that the kind of thing?
Both. We will actually have our developers tear down their systems and start from scratch. And when I say tear down, I mean uninstall everything. You have nothing on your machine. Go from scratch and build up. Now, we also do the same, and this was kind of a pain. We do the same in our cluster to make sure that we're covering all our documentation, the steps still are valid, something didn't change internally on AWS that'll cause us issues. So we also do the same thing on our cluster. We tear down our clusters. Well, not our formal clusters, but we basically tear down everything and go from a 0 to full deployment and try to check how long does it take us to do that.
Awesome. I heard it in production and staging, but I haven't heard someone do it in actually development environment. But it makes perfect sense. Like, hey, how fast can you get an IDE and your development set up, and what hold you back? That's cool. And we talk about it, but just for those, because I was curious about how you guys did it. If it was manual setup, my understanding is that most of the stuff you're measuring because you're using GitLab and their whole measuring thing. Yeah.
Now you'll see when I get to the examples, you'll see what we did for the code base. And again, just being clear, not to say that this probably can't be done with other stacks, but one, from some bad experiences, and two, moving to Quarkus has at least enabled us, as we've seen it, to be done better, more efficiently, and quicker with a lot less complication.
Nice.
So these are actually metrics, and I'll go through this really fast, but these have been collected over a 3-year period. So since the beginning of our platform, where we ended up to where we are now with Quarkus. And like I said, environment setup and configuration was pretty brutal in a 50-something microservice platform. We were talking about 1 to 2 days just to get set up. Then, because of the complexity of the system, the way it was set up and the way the modules interacted, you were easily looking at what we considered ramp up time, 1 to 2 weeks. So how quickly can a developer become acclimated to a code base where they know enough to maneuver around and start being productive? So just in that onboarding process itself, you're looking at somewhere around 1 to 2 weeks total to get a developer, a brand new developer, up and running. And we saw that this wasn't just brand new developers, it was also experienced developers. It took a lot of time to get set up. With Quarkus, we're usually looking at a worst case scenario right now of 3 days. We just recently did a fire drill here, and the average time to get set up and be able to get a general grasp of the code sat somewhere around a day. Now, when we get to the development life cycle, this is where it gets interesting. For us to be able to introduce a new feature or a bug fix and have it tested, we're talking about an average of almost 2 weeks. So that fits really within a sprint, and it really limits what we can do and how quickly we can do it. In Quarkus, we're seeing less than a week to get what we call first deployment. And first deployment isn't feature complete. It's all the pieces you need are there, and we've pushed them up, and you're deploying at this point into the cluster. So that's a huge difference in getting something out faster, either approving it or rejecting it faster, and it just makes the cycle overall quicker. When we get to deployment, again, similar types of issues. Configuration, depending on what it was, could be anywhere from an hour to 1 or 2 days to get that into play. We didn't have a preview environment. To deploy to staging for us could take 1 to 3 hours, depending on how many services we were deploying. And for production, we had to put that into a cadence of 1 production deploy per month, which right there is completely limiting. We wanted to get to the point of deploy at will. So deploy as quickly as you can get something validated, tested, and approved, and beg for forgiveness later. If it doesn't work or there's some problems, be ready to pull it out, but be able to do that as fast as we can deploy as well. A full deployment for us in Quarkus to date takes less than 30 minutes. It's 1 click, walk away, and we're done. It's out, it's deployed, it's running, it's been tested. Everything that we do.
Is that 1 service or all the services?
No, that's all of them. That's all of them. Now, keep in mind, this is all of them running in parallel, because when we hit the native side, it takes about 10 minutes.
Yeah,
but we
true.
parallelize that. But still, the other one is the same. We're running the same processes. It's just that it takes longer, and there's manual intervention to kind of go from one step to the next.
Okay. So you're using a mix. You have all native image, or is it
We did. We did. And that was icing on the cake. We didn't even plan to use native. Native was the least of our concerns. We wanted better Java.
Yeah.
Very first native app deployed out of the box, turned them all on. They all deployed. Where did we have our issues? That darn register for reflection. That literally has been the only issue that we have so far had that has really caused us a lot of pain. But we're working on our native test, better ways to catch that early. But that's really been our issue, is register for reflection.
Okay. But you run it in production, or you just have it as...
We're fully in staging, and for us, staging and production are exactly the same. The fact that we can make it into staging means our production deployment will, chances are extremely slim there'll be any differences.
Awesome. I have a question.
Sure.
This is like amazing to me that you have metrics and all these things. How do you collect all these metrics? Is that automated, or how does that work?
So GitLab actually provides the ability to track everything that happens within your pipelines. And if you think about it, they track everything from the ticket originally coming in all the way to the point of when you deploy it. So you have metrics on how long a ticket sits before in your backlog, when it's been worked on, and what a value is for coding time. Then you have a metric for when it's been merged, when it's been deployed, when it's been destroyed. So all of these metrics at a very high level and more than enough for our needs to demonstrate what we do internally are being collected through GitLab.
Very nice.
Gotcha. Thanks.
And then, outside of that, you've got your general, well, what's my CI process? Well, how many commits do I do a day? How many builds do I do a day? How many passed? How many failed? What days are, peak? What days are not? So there's a wide variety of data points that are recorded by GitLab. And then we also record our own with various tooling that we've wrote that tracks ticket time. How long does a ticket sit before the comment? I don't even know how many we probably spend more time tooling our own analytics than we do doing work anymore.
Well, it seems to pay off, because like when you can actually compare like before and after in a setting like this, you can really see what works and what doesn't, right? This is awesome.
It has. And it's important to get that visibility into the developer experience, because it's as important as the product itself. If your developers can't maneuver with the code base, you have a different set of issues, but you're detracting from being able to build out a world-class product.
So we actually have a question from, I have one question, is like the top pain points you list here is before Quarkus, right?
Yes.
Yeah, okay.
So, and this is really, so I'm going to skim these and then jump almost into examples.
So John Pellin is asking, is there a unit test suite or automated test suite in these build deploy numbers?
Oh, these are all fully automated. And we go through 3 layers of testing: functional, which is no dependencies; integration, which we consider to be data and core dependencies, data and Redis. And then we go through specific service-based testing, where we might have dependencies on Keycloak or Cogito or any outside services. So usually they require custom containers to go along with the build.
Yeah. So basically, the way you reach this is because you parallelized. Well, you have enough services, you simplify them so they're individually very fast to run, and then you have 50 in a parallel, or 30, or how many you have, and then you can, So the compounding effect is massive. So that's I'm impressed. Like,
no, you definitely have to, and you'll see when I pull up from the DevOps side, you definitely have to parallelize the build, especially when you get to the native side.
Yeah.
It just takes a while. But we were joking about this within. It takes a while, but I click a button, I walk away, I go have a cigarette, I go drink some coffee, I come back and everything's in my cluster, or it failed and 1 or 2 services maybe didn't make it. But that's rarely the case, because all the gates getting up to there, you would have failed way sooner.
Yeah. No, and that's the way they always, when people say, well, we don't want to use native because it takes too long to compile, and we say, well, you don't use it in your day-to-day work. It's in your, if you have an automated CI system, then it doesn't matter. Like, you spend 10 minutes to get get a much faster startup. So right.
Absolutely, and we have the ability. I mean, we run them day to day locally, but we don't run them all. I don't build a native image every 15 minutes on my local machine. I usually wait till I'm ready to merge. I'll test it locally, but we can test it in the merge request as well. So that's another nicety that we added, the ability to test that native image early, just run it through its integration test before it even gets merged in.
Nice. So we already have half an hour, so we have to get moving.
Crap. So I'll run through. So we come from a Spring Boot platform originally, and there were some significant pain points that we had with that Spring Boot platform. The crux of all of them really came down to auto configuration. That was a really big one. The bloated dependencies, the time consuming tests, build, Spring Boot run cycles, the opinionated conventions, which actually weren't always the best. And it got to a point where the whole concept of DI really started to become a burden for us, because we didn't trust the auto configuration, and we found ourselves writing a lot of boilerplate code just to get up and running with a basic service. And then, of course, the reactivity, when Project Reactor got introduced to Spring Boot and you had Web Flux, making that choice between, I'm either going to be reactive or I'm going to be blocking, that was a little bit of an issue for us, because at the time, this reactive APIs were very new, and you were going to have to write blocking code. So you needed to be able to write both. And that was a big issue for us. And we actually switched out. We didn't use Spring Reactive. We went to CXF, because even though we were still running on a web worker, that allowed us to do both imperative and reactive styles in the same place, which we thought was going to help to minimize the learning curve. This all comes down to, now I've got this huge ecosystem that, we look at examples and they say, okay, here's how we're going to build a Spring controller. It's pretty straightforward, but generally that's not a real world application. And as we found, the deeper we got into Spring Boot and configuration, it was starting to get ridiculously complex. We had auto configurations. We had jars that were being created to kind of cover Maven shortcomings. We had optional dependencies, and you didn't know where it was coming in. We had bloat or accidental triggers, again, because of auto configuration. Across the board, this started to affect how we test, how we build, how we deploy, what's our server density. Going from a 200 meg container down to a 50 meg container, which is an actual size now of our deployables, that goes a long way when you start to look at server density in a Kubernetes cluster. And, it has a bottom line on how much money I'm spending on nodes, especially when they're coming up dynamically. So this triggered this whole, how do we get better? How do we reduce this learning curve? Spring is, yes, what 70% of the developers are familiar with Spring and use it, but how deep do they really know Spring to the point where they can be productive, or are they just pulling things out of Google and slapping it in? And this became another problem because the ecosystem was so large. What we found is that there was never really a clear path to how you solved a problem. What you might inject or do in one scenario may or may not be the right Spring way. And Spring security is a really good example where there's 1,000 ways to solve that problem. And to this day, I can't tell you if we actually solve it the right way, because it had been in change and there's different APIs. They got rid of the resource server. It just goes on and on. These were the problems that we were seeing with ramping up new developers, building features, and the fragileness that started to evolve out of that was becoming problematic.
Interesting. So that's well, one of the, let's say not experiments, but approach we had to Quarkus is we, like, if we exist 20 years from now, we will also probably have a lot of extension and different things we change, but we do try and keep Quarkus to move forward. So if we do stuff and we mark them as this experimental and try them and get feedback, and then we're not afraid of in the next release saying, hey, this didn't make it, or we're going to change it for the actual final. So it'd be interesting to see. We definitely be a bit more aggressive in not breaking things. For users, we don't break things, but for extension writers, we're a bit more aggressive, exactly to avoid things getting stale or wrong or that kind of thing.
Well, what we found with moving to Quarkus, and in concept with extensions, and it is very likely, of course, to grow, but what we found was that it was a unified ecosystem. I could pull in Quarkus, and that was pretty much about it. Anything that I'm doing, I'm coming out of the Quarkus universe type bomb, and I'm not looking at explicit one-offs. The fact that there are, the use of the optional dependency was a complete mess, because in Quarkus, if I pull over Mongo Panache, I know exactly what I'm getting. I'm getting the dependencies that I expect to pull in. There's no guessing about what's going to turn on or turn off because I pulled in a starter. And the fact that, from a DI perspective, I might as well have written my own DI at this point, because what I want to do is inject a dependency by its interface, have that type recognized, and be able to start using it. These are things that we saw in Quarkus that sped up our development. The fact that Quarkus was built on standards, JAX-RS, the micro profile, our developers, we thought Spring Boot was going to have a much easier learning curve because, again, so many people are familiar with it. We found out that was completely opposite. More developers understood the Java standards than they did the Spring standards. And again, we had consistency that was starting to come out from our code because everybody was writing it the same way, using the Java that they're familiar with, and they were able to find solid pointers as to how to do things, not to mention the guides. The documentation from the Quarkus side, I'd found some pretty esoteric things inside your documentation that were exactly what I was looking for. All of the guides we were able to start up. They were deep enough to get you going. And they generally seemed, at least in our opinion, they seemed to really be real world problems that I could translate what you were showing me in the guide to something I really needed to do. When you get into a large scale system, I don't need hello world. I need something that's really kind of applicable to a problem I'm trying to solve, not the bare minimum, because the bare minimum gives you this false sense of security. I can easily get this up and running. And then 2 months later, you realize, this was a lot more complicated than I thought it was going to be. I didn't expect this. We have not found that yet in Quarkus. If I look at a guide, I can take that and within a few hours, extrapolate out what I need to do and be off and running. And that was something we actually found amazing as well with the move to Quarkus. I'm not guessing at where the documentation is. I don't know how many times I've pulled up the wrong page for the wrong version and implemented as something completely different, or couldn't figure out, well, why are these dependencies not here? What happened? So we felt that overall, Quarkus as an ecosystem was far more unified, far better documented, and always just enough. You didn't try to do more than I wanted. You did just what I needed. And I could see very easily where I could extend that if I needed to.
Very nice.
So, just to give you an example of the change in stack, this is how we went from Spring Boot to Quarkus. And in a lot of cases, we tried to stick to the Java standards. We didn't want to use the Spring way. So instead of using Spring Web Flux, we brought in CXF with Project Reactor manually. Well, now I had to tool that into the ecosystem because it didn't play the same. The same with AWS. I have Spring Cloud that came in and brought in all the dependencies with AWS. Then I had to go and exclude them out of my POM. I brought in S3. Just S3. They went a big way for the size of the jar. Security, just I go crazy on that one. Switching to Undertow. There was far more complexity that started to grow out of an enterprise Spring application for us than a lot of people might realize when they're just going in. But over time, these started to grow. They started to be very complicated. And we keep going back to auto configuration was starting to cause us issues because pretty much for every service where we had this grandiose vision that we could build this modular system, almost like OSGI or maybe even the new, Java 9 modules, what was happening was we were creating a web starter, a service starter, an API starter. So we usually had 2 or 3 starters that did nothing more than pull in dependencies. And then in the core code base, everything was optional. So you always had these issues of, do I need something? Am I missing something? And if you brought in the wrong dependencies, oh my God, you could flip all kinds of things on. That's where we saw this magical configuration that was really causing us a lot of problems and a lot of effort to just get up and running with the bare minimum.
So I see you have CXF listed on the left side. And you say it's replaced. What is it? Did you replace it with?
So we use CXF instead of pulling in Spring Web Flux, which brought in Netty and also forced you into, at the time, using the Spring controllers to be able to properly use the mono or Flux for reactive. We needed to be both blocking or imperative and reactive. So we switched out. We didn't pull in Web Flux as a core dependency. We used CXF with Undertow instead as our primary server, and then used its reactive stream implementation and its blocking implementation.
Okay.
And then you can see here too, Helm, Kubernetes. These are all things that we had to pull in just as a part of our core. when we went over to Quarkus, if you get rid of all the test dependencies, it's a pretty small surface area of dependencies.
Nice.
Yeah. But you don't have, what I'm saying, there's no CXF in the new stack. There's no.
No, we don't. We don't use it.
Yeah,
we got rid of it.
Yeah, from what I understand, it's like what KimJohn is saying is that the team didn't want to go full into the Spring way, quote unquote. So you guys wanted to rely on standards, right? So that meant you had to pull in all this different stuff, just because like the Spring way doesn't, it goes its own way. That's the whole point, right? There was no JAX RS in Spring. You need to do the Spring stuff. And like KimJohn mentioned, when the reactive stuff came out, that was really problematic, because that's pretty much the same thing that Eric was saying last week, that with Spring and reactive stuff, you need to make an upfront choice of whether you want to be reactive or not. And that's a pretty big choice.
Now, I'll say it was funny. I actually found a post dating back to 2020 where I started to investigate Quarkus, and I had questions. And one of my apprehensions originally was the use of Mutiny. Like, oh, another reactive API I have to learn. I don't know what I did before Mutiny. I love Mutiny so much. It's so nice to work in.
I want to tell everyone we haven't paid KimJohn anything.
I really do. I'll give you a classic example, and I like to think I'm no slouch in what I need to do. I've scored through the Project Reactor documentation, and I'll show some examples. Just really wrestled with it. I understood what I needed to do. I just couldn't figure out how to get there. Mutiny, I always joke, I can just spin it up, kind of brute force play with the, fewer methods that are, shortcutting. And I can usually get to where I have to go pretty fast. And I've really enjoyed working with Mutiny a lot. And you'll see too, from the reactive code, it's went a long way in simplifying how people write reactive code. And again, let's go back to the learning curve. Project Reactor is an awesome API, but it's extremely intricate and detailed. I have ranging skill sets of developers who may or may not really understand those concepts. Mutiny has helped to make that a lot easier to bring up everybody in how to write reactive code. And that's been that was a really big win for us.
I'm taking note of this because I know, Clement, this is literally when I came on Quarkus and I looked at Mutiny, I was like, what? Yeah, I had the same thing, like, why are we doing this? And I asked him, like, can you explain to me why again? And I'm not saying word for word, but literally what you just outlined of, like, reduce the complexity, have an API that's a bit more natural, simplify, and avoid all these weird issues. Was literally his goal. And I can tell you that, like, last year I've seen issues coming in, and people try and apply Reactor, and then boom, you end up with, like, oh, they think Mutiny is doing it wrong, and what it turns out is that they actually use Reactor wrong. So when it's Mutiny, where things behave, let's say not so predictable, but it's just been very interesting. So I know Clement will be very happy to hear that he has a soulmate here of simplifying. Yeah.
Well, and that's actually interesting. So I just recently posted on the Quarkus news group and then followed up on the Mutiny news group, because one of the things that we noticed was from the Spring side, mono and flux were always used, whether it was a collection or not. And so I realized in the Mutiny documentation, oftentimes that was in UNI with a list. So I asked the question of what is the preferable approach? And it was a very clear and concise answer from the Mutiny team of using the UNI list when you knew you had a fixed collection or a specified collection coming back, and it wasn't in reality a stream. And you might think that's maybe a dumb question, but that clarification of when do you use a multi, when do you use a flux, it really helped to clarify how that interacted with the upstream and the downstream operators. And so
that question comes up so often. I mean, it's so not dumb. It's so important. It's a huge.
But that comes from the fact that in reactor everything is considered.
Yeah, exactly.
Stream,
in
right?
reactor, it's all.
And where we go, like not everything is a stream. Right?
Exactly. Yeah.
Yeah.
Well, here's the cool thing. So I heard that we had already went down the multipath, so we were misusing it. One day across the whole code base was able to convert everything, test cases ran, and we were out the door. This was just last weekend too.
Yeah, well, I mean, your whole presentation is about like agility. Everything is like moves you into the path where you can actually make changes so quickly and see things that work or don't. Right? That's huge.
Well, let's get into the examples, and let's start out with auto configuration. Again, we've already talked about the bloat of dependencies and having a bunch of dependencies that do nothing more than say it's not optional anymore. And outside of the fact that you have core dependencies that are all marked as optional, which by itself is problematic because now I have a guessing game of what do I actually need to turn it on unless I bring in a starter. We went through numerous refactorings and ended up closer to the Spring path where we had a super module that had all kinds of configurations for every service that had to be built. And this was one of the steps that needed to be taken to get anything into play. Now, when you have this many configurations, what happens that nobody really points out is you have an ordering issue that you need to take into account. And that is really, in a way, really complicated. I need to know what's going to be loaded before and after and almost kind of dictate in my configurations where things are going to happen, because I may inject a bean and it's not ready for injection because another dependency isn't there. So as you start to build out, or as our platform started to build out, we're building all these configurations, and now we're manually ordering, well, this one needs to come after this, or this needs to come before this. That by itself is a huge barrier for developers because they need to understand what's being put into play, when is it being put into play, how is it being put into play, and this is even before we get to injection. So creating all of these configurations, at first it seemed like a great idea, but it started to become extremely complicated and magical. And there's different rules. If I have a static inner class, how does that get loaded? If I'm conditional on bean, if I'm conditional on class. What ended up happening is a lot of the configurations turned into feature flag type configurations. Crap, I'm not going to deal with this. I'm going to put a property in my application config, and if it's on or off, I'm going to turn this on. And that's how, things started to change. Now, because we don't use component scanning. So what that basically means is we have to create all of our beans, and we actually have to wire them up, which in this case is nothing more than really calling its constructor and manually providing what that configuration is. So
why didn't you not use the component scanner thing?
Because component scan there's always the potential that through component scanning, we're going to introduce unwanted dependencies. And then we also just didn't have the visibility into what was being injected because who knows? It's scanning and it's picking them up and throwing them into Spring. Not to mention, again, we get back into an ordering issue. I need to be able to control these configurations, and having half of them being picked up by auto scanning and then 3 or 4 picked up by configuration, we found that to be more complicated because now I don't know what's going in where.
So this because we have the same in Quarkus, right? We look at a class like in the dependencies, and that gets available to you. But I guess what you're seeing is that in Spring you got too much added to your class path, and therefore you got stuff you didn't expect. Is that the?
Oh, absolutely. But see, in Quarkus, we don't have to build configurations unless I'm building like some custom provider.
Yeah.
I can, by type, and this is actually really important, by the type itself, use Jandex, which scans in and of course builds that index. And then I can literally hit the ground running and say inject. And it's either there or it's not, and you catch it. With the auto configuration, because we're not using the auto scanning, we have to create the equivalent of that and wire them up ourselves, which in most cases, again, for us, this means just basically calling down to a constructor, trying to find one that'll show, and passing in what we need. So really what we're doing is, in a sense, manually creating the module or the injections that now can be used through the other services. But we have the step of creating a configuration, which we do not in Quarkus.
Very cool. So I see we already almost on an hour, but I want to hear more. So let's go.
So this becomes really problematic again. And another part where Quarkus, well, let's go to the Quarkus side.
And by the way, for anyone who's listening, please, let us know if you recognize this, or is Kim just seeing this as a very unique person?
So we go to the Quarkus.
It's not unique. I've heard this plenty of times.
Oh, actually, trying to think what's the best way to demonstrate this. So let me just show you what our project looks like from a package level. Not necessarily, I mean, well, it's pretty much a one-to-one to a POM level, but we have a platform. Then we have our API. Then we have config. And again, that just goes on forever. Then, because we needed to separate web applications from service applications, we have these RESTful configurations, which have their own web configuration, because we had to separate those. Because if you didn't separate them, what would happen is the configuration would pull in too much and it would turn on service level things when all we really wanted was a RESTful endpoint at this point. So with this too, what comes out of this, which was really kind of nasty, was because the configurations are wired in a specific order, or if they're left alone, they come into play whenever they can. That meant property configuration became very hard to consolidate. And because of that ordering, we had to write our own module post processor to try to figure out how to layer the properties on top of each other so that if a jar came after it should have, it didn't stomp on the properties that you really wanted. When we went to Quarkus, this is literally our Quarkus build. And also what's really neat to see here, we wanted to get rid of all the different IDEs that everyone was using, at least as a basis. When we moved to Quarkus, because of the way that it was structured, because we weren't playing with all these weird Maven tricks, we were actually able to pull this into VS Code and standardize across the board, whether it's Java, Python, Node, whatever. We were able to standardize across the board using VS Code.
And are you using the Quagga extensions or just plain the Java?
I have it in there, but I don't know if I use it very much.
Sure.
I mean, the point being is that it was so simplified that VS Code didn't go crazy with the Maven dependencies. It literally looked at it as a standard Java project, and we were able to I do everything now. I don't even know the last time I've opened up IntelliJ.
Cool.
The other thing that's been nice by consolidating in VS Code is all of our onboarding that used to be separate projects. A lot of those we can actually set up as a part of that VS Code configuration. So external containers or anything that goes along with this whole service is now included in this single checkout.
Very nice.
Now, the equivalent, so even if, we go back to Spring. Sorry, I keep flipping through all these windows. Oops. Oh, yeah. So if I go here and we just look at the Maven POM. Now, again, remember, from the Maven side, that in itself, oh, wait, this is another example. Oops. Now, see, remember I was saying I might get overexcited, and then it gets I start going all over the place.
Is that now? Okay.
This is pretty much now where I'm like too excited now. And my window is really big, so I'm trying to find everything.
That works.
So if we look at our POM, and this is just the parent POM, because we're doing a lot to play on the same Maven tactics with configuration properties and everything, it's a pretty sizable POM with a decent amount of profiles to do the switching. So, I mean, we're talking here 1,000 lines for that POM. Now, when I go back to my Quarkus POM, and I'll go to the equivalent, it's half the size. I'm not doing Maven magic to get things up and running. Literally pulling in. We standardize all our test dependencies, but I'm literally pulling in the Quarkus BOM and I'm out the door running. I don't have a single profile in this POM. Where I use profiles is when I'm flipping between my native build or even on the CI area. This allowed us to then take it further. And in our API dependency, really at a high level set, what do we want all of our base configurations to be? And because we had predictability in how these were being loaded and how they were being injected, this carries down. And if I choose to override it, it's a lot easier and a lot more predictable about where I need to do that.
Cool.
So this literally builds our Kubernetes. This is our Kubernetes cluster. All services inherit this, and I'm done. I don't have to, if I go to a project or a service, an individual service.
Is this are you merging this with the one we generate, or is this something else?
No. So I actually generate it as is, and then when it gets to the build server, there's certain things I need to change to manage it within my environment. So we even track the services within GitLab, and our developers through GitLab can actually pull up the logs or look at the service. We have a no AWS rule, and none of our developers have direct access to AWS. If they can't do it through GitLab, they don't get to it. So we don't expose that to all the developers. But this is pretty much your out of the box Kubernetes config, and then Kubernetes manifest. And then again, this is used across the board. So when I get into individual services, I mean, that's the application property at the service level for every service.
So you're not using the generator we do?
Yeah, no. This is your generator. It just generates, because I can carry and inherit that. Each of the projects all pull in the API dependency. Your generator sees the API dependency and generates it within the project.
Yeah, it's just configured with various labels and annotations.
Mm-hmm. Got it. Okay. Very nice.
Of course, I didn't generate a Kubernetes one in here. But no, everything in here is completely using everything out of Quarkus. And that's, again, this keeps going back to I don't have all that tooling that I needed to do. I don't have a bunch of Helm charts that we're managing to run this.
This is great because this is so hard to explain to some people who don't know. Like one of the things I like about Java is the fact that there is this whole ecosystem. Like I have Maven or Gradle, and then off you go. In the recent world, that like, oh, now you have to have kubectl and whatever scaffold, whatever thing installed to get going. And which is fine. Like I think it's great that the rest of the ecosystem has it, but in Java world we have all this automation and stuff, and it's a shame not to enable it. So this is great that you kind of push it to where it fits very well. You have a very unified set of applications, and there it shines. Like there's no need to have a different set, and that simplifies your life. That's very nice.
Oh, everything about it has simplified our life. So if I look at, and I won't even pull this up in my other example, if I look at the equivalent code for our project service, I mean, that's it. I don't have configurations all over the place. I don't have a bunch of application properties that I need to override because I need to do it at the last jar loaded, not the higher jar loaded. So being confined to working within one package, because like you mentioned, I mean, you can get pretty deep in Java, and that tends to be the drawback. And a lot of developers, have a little fear of, oh my God, it's so verbose. But if I can consolidate you to working within your package and you have full reign, right there, I have alleviated half of the problems that people will say is why they won't use Java.
Yeah.
And so we don't have, again, no configurations, pretty straightforward, inject. We actually looked at Juice because it had a very similar, but it had a predictable approach to how it handled injection. Even though you still had to wire up through the modules, you still knew what was being injected where. I have yet to come across a place in all of the code that we've migrated where injection hasn't done what I've expected it to, or if it did stop me, it was because I actually really didn't have an implementation to back that up.
Cool. And the way you guys do development, like locally, it's just you run Quarkus dev and that's it? Or
we run Quarkus dev, but then we took it a step further, and this is pretty cool. So we have a shortcut within each of our services, or within each of our groups, because we can do a mono repository style where each service is in there but deployed individually, or we can do an individual service style. But what we do is we create a bootstrap. And what that does is it aggregates all our services together. So instead of me having to run each one individually, I can spin them all up inside that bootstrap and then run another service that talks to it.
So bootstrap, you mean like just like
think of it
container? So you like literally go and run all?
No, I'm running them without a container. That was something that worked really well. Again, because the dependencies were predictable. And when we build services, we knew what was being pulled in. Using the bootstrap lets me spin up all of the services within, just spin them up in Quarkus dev and start coding against them if I needed to, or even making changes, because another difference, the Spring Dev tools didn't, at least at the time we used it, didn't work well with multi-module projects. Here, if I make a change to project or I make a change to query, it'll pick it up automatically and reflect that change. So I don't have to go through that big build cycle. And this just lets me shortcut all my services instead of spinning each one up individually or deploying them into the cluster locally.
Very nice.
Well, we take it a step further. This is even better. So we now tie in wire mock. So as a part of our standard build from the test side, right now, but we're moving it towards, we're actually trying to build an extension in Quarkus Dev to tie it into the standard run. I can spin up any single service as if I had the whole cluster, because WireMock is providing to me everything that's outside of that service. So we're trying to get it down to the point, we're pretty close, where we can just run the individual service with no other dependencies at all.
Yeah, that's yeah, I remember we've talked about this on the list as well. That's something that we have on our roadmap as well, but we haven't really looked into it. But yeah, if you're close, then yeah, that's definitely something we want to look into, want to see.
We're definitely doing it in our test cases, which has been it's been huge for us, because again, if the idea is to isolate a developer to working just with what they need to work with, I don't want to look all over the board. I don't want to keep bouncing around which modules or dependencies. So right now with our test, I can effectively test any given service completely on its own. I don't have to spin up a bunch of stuff to support it. WireMock gives me what's outside. I focus on my service. I tweak the WireMock if I need to. I can run just that service alone. And we added the ability to WireMock so that we provide a core set of functionality, but then you can take it further and create custom functionality, custom payloads within your service, because each service effectively has different payloads, different requests, but we do have a standard core set of services. So that way a developer can come in and they can just stub out what they need. We'll provide all the basics and you just build your differences.
I'd be very interested to hear about that bootstrap and your WireMocking thing. It sounds like it could be generically useful.
It makes it generic. So even, again, common problem in the microservice space is how do you tie these all together and how do you develop effectively? How do you, when you have 50 services and you're working on one, but it depends on 49, how do you get those 49 into there with little complication, or having to know I have to start a container, I have to do this, things like that. So for us, this one project that you see here, and a little bit of a slightly different style or structure that we took, a mono repository type approach. Each one of these services gets built out as a native service and deployed into the cluster. This also gives us an ability, because again, we can predict what those dependencies are, to later build what we consider more functional type services. And it helps to minimize the size, because if I'm not bringing in Mongo, I have no reason to, then don't bring it in. So services that are pure executors, for example, they don't need Mongo. They're getting invoked through a REST client from the upper services. And these are just running with whatever dependencies they need. So we get to keep our sizes down, and we don't bring in what we don't need.
Very nice.
When we're building out stuff.
Very cool.
Yeah.
So, do you want anything else you want to add, KimJohn? Because we're over time now.
Yeah. I didn't get. That's the. So this is actually a prototype that was done in less than a week, taking our services and pumping it to a Thea IDE with Cogito. But I actually wanted to show the build process.
Well, go ahead. We have.
So I pull over these windows here. So this is where it all starts to come together. How do you tie this all together into a single?
A bit more.
Pardon me?
Just zoom in a little bit.
Oh,
just a tad.
This is Control Plus.
Yeah, something like that.
There we go.
Awesome. Good.
So this is where it really all comes together. Quarkus simplified the whole environment. It made everything consolidated. It kept the code base clean. It kept the dependencies clean. It kept the Maven POM simple. Now we have this amazing set of services that can be built rapidly, built rapidly, tested rapidly, and are ready for deployment. The next step in this process for us, which we, at the same time that we migrated to Quarkus, we started from the ground up, was making sure that the whole CI/CD environment played in every step of that process. So for us, we're very merge dependent. You basically get to a merge request at some point. So once you've created that merge request, what we want to be able to do is test the service or services that you've touched only in an isolated fashion. And what that means is being able to deploy just your service and have it configured to point the rest of your services to staging. When a developer creates a merge request, they have the ability to deploy whatever services they touched into their own isolated environment and test them before they get merged in. Once they're ready with their service, it's complete, and it gets merged in. Let me find, I've got all these tabs. Let me figure out which one's the main tab. I'll just go back to the pipeline. So once it gets merged in at the master or main, depending on what you're going, we're now ready to promote that or push it. Clicking this promote in turn goes out does all the tagging and the version orchestration, and it builds every single service and pushes it out to an environment. So for us, once you've merged into master, it's a completely automated process from master to either of our environments to build a service natively, test the service, and deploy it.
Very nice.
And we can literally, so if you look at any one of these given services,
automation for the win. Automation.
It's slick. It's slick. And the other thing that's really key here, so
how big is your build cluster or your setup here?
Which one? The one we're deploying to, or what we run in production to date?
The one that's building, not the.
So these are all built. So with GitLab, we're using autoscalers. We just spin up as many spot instances as we need, and when we're done, they just they get thrown away.
Nice.
So we spend effectively. We're running the native builds on a little bit of a higher instance, but we essentially spend a few bucks to do a full build. What was I showing? Oh yeah, so this is actually really cool.
Totally worth it.
Oh, it's so worth it. So worth it. So all this automation is accomplished primarily through this one setup on the Quarkus side. And what's neat is we push all of these assets to AWS. So at any given time, I can roll back to an old version, or I can go and redeploy a version. And we're starting to explore re-augmenting the native build if we needed to. So for an end developer, where it gets, just to give you a kind of an example. And again, to bring up one of these services into the cluster, because the way that Quarkus is consolidated so much, it literally takes about 5 minutes for me to bring in a brand new service and be able to deploy it. And we don't even have to have a DevOps guy involved. It just happens automatically. And so with any service, you can do this. And once it deploys, you're basically good to go to start testing it. So here's a running Thea IDE interacting with services mixed across both a local node and or a namespace specific to the branch, as well as staging services where nothing changed.
Cool. Okay, so you deployed. That's after your build has been run. Then you have access to like a scripture for Thea saying, "Hey, open it on this configuration." Is that it?
We deploy Thea too.
Ah, okay.
This is just another build for us.
Got it. Oh, okay.
Yeah, this is just another build. No different than any other build that we have, but when it deploys, it's completely wired in to the rest of the Quarkus services. Because again, it's so nice. We can do this. I'll show you where we do it. So you remember you saw the manifest that comes out of that one API. When we're in the Quarkus service, let me minimize this. Let me figure out which job is that Quarkus service here. So this actually goes through and does the native build. Oh, I take that back. Everything's already set up at the point that we've done the native build.
Okay.
So when we get to a deploy job, or we're ready to deploy, it's really more a question of what's the rule. Can I deploy it to staging? Can I deploy it to production? If it's a merge request, I can only deploy what's in services, and that pushes it out.
Very cool. Excellent. I must say I'm impressed with all the stuff you managed to automate.
Yeah, there's so much stuff going on. It's amazing.
It's honestly our biggest regret is why, we should have probably started earlier. Oh, I can even run through. So we even have, this is another nice thing about using VS Code. We got rid of Postman. We got rid of all the database IDEs. We can do most of what we need to do within Postman. I can even walk through and smoke test the whole site. Oh yeah, and then now we're building our own VS Code, of course.
Next level stuff.
Awesome.
Very so that's pretty much our show and tell there.
Wow, that's great stuff.
That was very cool. What's next? Or what can we do better? Or what should we not do?
Well, for us, we're focusing the rest of this year hardening our new platform, which we've christened as Fusion. We're rolling in a completely new set of features and services around data federation. Cogito is very big on our list now, moving to full execution Cogito. But really for us, as much as we move rapidly, we like to make sure we have everything in place so that we can move rapidly in the future as well. So it's really going to be a lot of hardening on the overall platform. We'll be starting to integrate the telemetry and logging out of Quarkus. That probably, honestly, it's not a huge, we're primarily focused on building out features at this point. We've already migrated the core foundation of our framework and are not having any problems.
Basically, what I heard you saying is that for Quarkus, it simplified all the basics. It avoided you to have a lot of a lot of scaffolding code of configuration and setup. And then combined with your GitLab setup, you could literally just parallelize everything, and you're down to what's it called? A turnaround of less than 30 minutes for a whole full deployment, which is pretty amazing.
And we're down to just writing code.
Yeah. And one thing, when I read I saw your draft first time, you said you're deploying everything at once, but I understand you don't have to deploy everything at once. You can also just say, I'm just updating that one dependency and that one service.
Exactly.
Because I was like, oh, if you have to deploy everything, you basically have to deal with a monolith. But it sounds like you have a big system, but you can do subparts of it too.
Mm-hmm.
So
well, each one, we took an interesting approach with the mono repository where each one of these represents a service. And our approach to designing services is that services do not have cross dependencies. If they need to talk to another service, they'll do it via the REST client. So that way we had an issue again with the configuration in our Spring platform. If I had a fix in project, for example, that was being pulled into the other services and hence they needed to be redeployed as well. So we maintain that all services can only communicate to each other over the rest of a client, like an IPC, but that allows us then to make fixes to specific services and not have to go through a full.
Yes, you don't have and you also don't allow them to have a shared implementation of whatever they do, right? So
exactly.
They have, if you're talking to a customer service, there's 5 services that does that. They all have their either custom DTO or custom resource or whatever.
Exactly. And again, that went a long way because as we refactored configurations, we had to try, it was better for us to try to centralize those into shared modules, which then, one module needs this property, but the other one doesn't, but it needs this. So you just got into this cycle where you couldn't be very specific within what you wanted to do.
Yeah. No,
and projects, projects actually one of our higher level ones. But if I look at something like query, everything really is in here. So if I have an entity, it's here. If I have the service, it's here. If I have a resource, again, it's here. And nothing stops me from creating different resources, but at least it's confined and I don't have to worry about any cascading explosions.
Yeah. So you have a price of some duplication, but the return is that you are like independent and can handle it. Yeah. Very
and
nice.
Then we have a core platform, and our core, honestly, this is more just a nicety for understanding. We have our API, primarily interfaces and RESTful clients, but this is shared across. And then we have the concept of what would be more closer to components. These can be reused, but not these. So I could never have a hard dependency on project inside of query, except through the client, but I can use any of the components as needed. And again, they bring along their dependencies, so I don't have to worry about configuration at that point.
Awesome. Okay. Well, anything else on the last thing? Otherwise, we will have to wrap up over time now.
I've probably taken up all the time.
Well, and a bit more, but it was good. It was very interesting. I didn't want to stop you because it was good.
Yeah,
that was great.
Amazing insights. It's like the epitome of insights.
Yeah, I would love to see it because you did all the stuff that you say people should do. So and you got the gains from it. So that was really, really good to see. So congratulations.
Oh, thank you. No, thank you. We've been
Okay.
really happy with Quarkus. We're fully vested in it now at this point. It's all steam ahead for us on this path.
Awesome. Maybe we should that too, Joe.
Excuse me?
Maybe we should also go full in on Quarkus now. No, that was good. So anyway, KimJohn, thank you. And it seems like you have a ton of stuff to talk about, so maybe we will bring you up again.
Okay.
And if you do anything you had this orchestration of all the services and the bootstrap, that sounds pretty usable. So if you want to
definitely
that
bring
off
that
and
up
have a conversation
to us.
and maybe something you can contribute back, that sounds great because we've done all the dev services now with but being able to also wire up the product's own services in an interesting way is kind of the next step that we would like to kind of explore if we can do without too much invasive stuff. So cool. Well, anyway, thank you, and
Awesome.
for those who listen, so stuck around, thank you for staying around.
Thank you.
We'll see you around next time. So I'll say bye-bye.